So using the law of sines in a triangle ABC, we need to show that the given trigonometric equation holds true. Let us begin. First, we'll define the law of sines. For that, we will consider a triangle ABC whose sides opposite to angle ABC are represented by the letters A, B and C in lowercase. Then the law of sine states that the ratio of side A to that of the sine of the angle opposite to A will be equals to ratio of side B to that of sine of the angle opposite to side B. And that's also equals to the ratio of side C to that of sine of the angle opposite to side C. This is the law of sines. And what we'll do, we will suppose that these three ratios are equals to a constant lambda, such that A can be represented as lambda times sine A. Then B will be equals to lambda times sine B, and C will be equals to lambda times sine C. Right. So we'll start from the left hand side of our equation. So here in the first term we have A multiplied to sine A over 2. So we'll not touch the sine A here, we'll keep as it is. Now let's work with sine A over 2. Now we know that in a triangle, the sum of the interior angles is pi. That means we know A plus B plus C equals to pi radian. So what we can do, in place of A, we can replace it with pi minus B plus C. So here we have sine of, now in place of A, we can rewrite it as pi minus B plus C, whole divided by 2. Multiplied to sine B minus C over 2. Coming to the next term, we have B times sine B over 2. Now the B in the numerator can be replaced with pi minus C plus A divided by 2, multiplied to sine C minus A over 2. And the last term is C times sine C over 2. So we're going to replace the value of C with pi minus A plus B divided by 2. And also this is multiplied with sine of A minus B over 2. Fine. That means we now have A multiplied to, so what's the value of sine pi over 2 minus B over 2? So this becomes cosine. So we get cosine of B plus C over 2 multiplied to sine B minus C over 2. This is our first term. Then the next term is going to become B times, so sine pi minus C plus A over 2 will become cosine of C plus A over 2 multiplied to sine C minus A over 2. And the third term will become C multiplied to, we have cosine of A plus B over 2 multiplied to sine A minus B over 2. Fine. Now what we'll do, we'll multiply each term with the factor 2. But since it's an extra term, so we are also going to divide by 2. So we have B over 2 and C over 2. Now that is done because we can apply the formula here that whenever we have cosine of theta plus phi over 2 multiplied to sine theta minus phi over 2, and we have a factor 2 multiplied to it. So this is equivalent to sine theta minus sine phi. Right. So that means our first term will become, we have A over 2. So this is simply sine of B minus sine C. Then the next term is going to become B over 2 multiplied to sine C minus sine A. And the third term is going to become C over 2 multiplied to sine A minus sine B. Fine. So let's multiply with A. We're going to take half as the common factor from each of the three terms. We get A sine B minus A sine C plus B sine C minus B sine A plus C sine A minus C sine B. Now we have defined the value of A, B and C. So that's lambda times sine A, B is lambda times sine B and C is lambda times sine C. So let's introduce this value in place of A, B and C. Now we will have lambda in each of the terms. So we can factor that lambda out. So we have lambda times 2 multiplied to, we have sine A times sine B minus sine A times sine C plus sine B times sine C minus sine B times sine A plus sine C times sine A minus sine C times sine B. Right. So let's see if any terms that gets cancelled out. So we have sine A sine B. So this and negative sine B sine A cancels out. Then we have negative sine A sine C. So negative positive sine A sine C. We have positive sine B sine C. That cancels out with negative sine C sine B. So we are now left with lambda over 2 multiplied to 0. So this is 0, which is the expression on the right hand side. That means we have successfully proved the given problem that the given trigonometric equation holds true.